Hello everyone, welcome to this video on joint distribution in probability theory. If you ever wonder how multiple random variables behave together, joint distribution is the key to understand their relationship. So in this video, we will cover what is joint distribution, the difference between discrete and continuous joint distribution, concept key concepts like marginal and constant distribution. We'll also check how two random variables are independent, and we will see the real life example and solve the problems to make learning easy. So let's dive right in it. So in probability, we often deal with more than one or random variable at a time. For example, what is the probability that a student who score high in maths also score high in science? And what is the probability that a factory produces a defective product under specific conditions? So, joint distribution helps us study the relationship between these variables. It tells us how the probability of one random variable depends on another. In simple terms, it helps us understand the pattern between multiple factors. So here are the key properties. The PDF is always non-negative and the total probability must sum up to 1. So when we study joint distribution, we often deal with bivariant random variables, which means two variables at once. For example, X is equals to the number of heads in first flip coin, and we can say Y is the number of heads in the second flip coin. So together X and Y forms of bivariant random variables, and when we can analyze how the probability of these two variables change together. So here are the types of joint distribution. First is discrete joint distribution is when used both x and y have countable values, example rolling two dice, and second is continuous joint distribution is when x and y can take any value within a range, for example height and weight of a people. In both cases, we use different mathematical functions to describe their probabilities, which we will see in next. So a discrete joint distribution is probability distribution that describes the probability of multiple discrete random variables occurring simultaneously. In discrete joint distribution, we use the probability mass function is also denoted or represented as PMF. For example, Px is equals to 2 and y is equals to 3 gives the probability of a rolling a 2 on a die 1 and a 3 on a die 2. These probabilities are listed in a table format and must always sum to 1. So continuous joint distribution. A joint distribution describes the probability distribution of two or more continuous random variables occurring together. For example, we can also it is also denoted as PDF. Unlike the PMF, which always give exact possibilities, the PDF describes the density of probability over an interval. For example, if x and y represent height and weight, we cannot find the probability of someone being exactly 170 centimeter or 65 kg. Instead, we find the probability of being between 70 to 71 or 65 to 66 kg using integration. So this is the example. So marginal distribution. Sometimes we only want to look at one variable and ignore the others. This is where marginal distribution comes in. When we calculate the marginal distribution by summing for discrete random variables or integrating for continuous variable over the other variable. For example, in a classroom study on test scores, we may only want the distribution of scores, ignoring physics scores. So marginal distribution Also describes the individual distribution of x and y without considering the value of the other variable. They are also obtained by summing in the discrete case or integrating in the continuous case. The joint distribution is over the other variable. So the next one is conditional distribution. So in conditional distribution helps us answer the questions like what is the probability of a student passing science given they have scored well in maths? And the other is what is the probability of a rain given that it's cloudy? So the formula shows that we have divide the total joint probability by the marginal probability of the unknown variable. So conditional distribution describes the distribution of one variable given specific values or range of the other variables. So here comes the independence. So if two random variables are independent, knowing if one does not affect the probability of the other. For example, the outcome of rolling a die does not affect the outcome of the rolling flipping a coin. But a student's math score might affect their physics scores, meaning their variables are not independent. So, two random variables x and y are independent. Knowing the value of one provides no information about the other. Regarding joint distribution, x and y are independent if the joint distribution factor into the product of their marginal distribution. So now let's test your understanding. Try solve these questions and check if x and y are independent. So thank you. That's it for today. If this helped, like, share and subscribe. Drop any question in the comment and I will be happy to help. See you in next one. Bye bye.